Welcome to the AI for You Cafe. We're waiting until the participants all arrive. Today we have the live presentation, which is themed Data Sovereignty as a Key Enabler for AI in Europe. So my name is Carmen McWilliams, and I'm the moderator and organizer. And our speaker today is Sebastian Steinbusch, the lead architect of the International Data Spaces Association, which I will shortly introduce when everybody's in. Again, I will tell you the little rules of this cafe. Please take notice that the session will be recorded. The recording of this live web session will be available afterwards on our AI for You website. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project opinion. And I welcome you all. I'm very happy you're here. And I want to tell you that on the right side, you have a panel. You can ask after the presentation questions. There is on the panel a function called questions. You can type it in. Afterwards, I will read these questions to the speaker. Or you can even raise your hand. There is a hand button function. And then after the presentation, I can even give you the mic if you wish. So now I will turn my presentation. A moment. And what is the AI Cafe about? The AI Cafe is an online forum to gain insights into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders in various areas of AI research and applications. And if you wish to be a speaker in the future, please apply directly to me. So now we're coming to the live presentation of Sebastian. Why you're all here, I shortly introduce Sebastian. Sebastian Steinbusch worked for 9 years at the Fraunhofer Institute for Software and System Engineering in Dortmund as scientist in the context of cloud computing, big data, and IoT. Here he gathered experiences regarding digitization in logistics and service industries. Since 2017, he's the lead architect of the International Data Spaces Association, in short IDSA. Here he is responsible for the technical development of the IDS and the organization of the IDSA working groups. Hello, Sebastian. Hello. Maybe you say hello. Hi. Great that you're here. Hi. I'm very proud to present you in our AI for You Cafe. And I will now give you, of course, the chance to make your presentation. I will give you the control. One moment. It always takes a moment. I have to change the moderator role. And now you are the moderator. And if you wish, you can show your presentation. I see it. It looks great.
Very good. And so
the floor is yours.
Thank you, Carmen. Thank you, Carmen. Thanks to all of you to be here today. It's a pleasure for me to be here in the AI for EU Cafe and to talk a little bit about IDSA and data sovereignty as a key enabler for artificial intelligence in Europe. So we as the IDSA, we're working on the topic of data sovereignty for roughly 4 years. And today I want to talk to you all about this topic because it's very important if we talk about data sharing, data exchange, and things like AI and cloud computing to think about data sovereignty. So what we do see, IDSA is working since, as I already said, for 4 years on the topic of data exchange and data sharing between companies and in different industries. So, and what we need is something like a clean room for the prospering data economy. We need something like defined usage constraints. We need a governance model for this data sharing, and we need an area for the trusted manipulation of data, for the trusted usage of data. And this is basically what we're working on, to enable data exchange and data sharing while maintaining data sovereignty for the provider of the data. So we have an idea how to define data sovereignty. On the one side, we think that we need interoperability to share data between companies. We want to have this data exchange. We want to move forward the sharing economy for data, and we all want to provide those cool data-centric services or smart data services on the one hand side. On the other hand side, we have to think about data ownership. What are the usage policies, the rights to share the data, how to maintain the security of the data, and how to really find the value in the data. And this is where we came to the idea of data sovereignty as the ability of a natural or legal person to exclusively and sovereignly decide concerning the usage of data as an economic asset. So that's our idea, why we want to share data and what is the main goal of sharing data to maintain data sovereignty. So why is data an economic asset today? Data is available today from a lot of different sources. We have technical drawings, for example. We have financial data. We have mobility data, material characteristics, sensor data, customer data, all those different kind of data. But this data only gets value when it gets used. And you can only use the data really when you can link it with other data from other data sources, and you can really gain value out of the data. But there are a lot of hurdles today in making data really an economic asset for the industry. Today, trading with data creates typically huge revenues for some focal companies in an ecosystem, which then tend to assume monopolistic attitudes. So, and rarely the creators of the data are really benefiting from this value in an adequate way. I'm skipping an example for this. I think all of you can have an own idea about examples. If you want to make the data sharing economy really a success, we do need vendor independent data marketplaces. And this can be only achieved by connecting those vendor specific platforms. It shall be open to all, and it shall be available at low transaction cost, and it has to be easy to adopt and easy to use. For the IDSA, I can say we're working on the first items really hard and achieved a lot of things to make it really easy to adopt and easy to use. We have a way to go with regards to this. So we as the IDSA, we really address these needs. We define a reference architecture model that formed the foundation, the base for an open distributed data marketplace that ensures data sovereignty for the creator of the data. And proven data provenance for the user of the data, if necessary, audit-proof. And all this is based on the European values. So what we really deliver, first of all, is a reference architecture. Our reference architecture model is a standard, a definition, how to set up those data spaces. What is the governance in those data spaces, and what is the foundation of those data spaces? Of course, we also define interfaces because we need some technical work to really exchange data. But we also are working on a contractual framework to put this really in a frame where we can exchange data in industrial and in commercial way. And we do provide sample code. We are discussing as IDSA to also provide open source code to become an open source foundation. But today IDSA is not an open source foundation, but we do have sample code to provide. And there are existing implementations of IDS components available as open source. So we are an association, as already mentioned. We have today more than 100 members from different industries, from different countries. We started in Germany as a small association with 18 members roughly 4 years ago. We have members from Germany, small, mid-sized companies, but also large international companies, like example ThyssenKrupp or Siemens. We are very strong all about Europe. A lot of European companies joined us, but we have also companies in our association that come from non-European states, like Japan or Malaysia, for example. And we do have really currently more than 300 people contributing to this standard and implementing things based on IDS, may it be implementing technology showcases, proof of concepts, or business cases, how to really implement data usage and data economy use cases. So the core idea of IDS is not to build the next big platform, the one platform that rules them all, that collects all the data in one central place. IDS is a peer-to-peer approach. And we want to connect all those existing systems that bring value to the companies, starting from the shop floor, from robots, from machines, from trucks, from the logistics, connecting enterprise clouds, industrial data clouds, enabling data marketplaces, and so on and so forth. And of course, including also open data. So the idea is really that IDS can connect all those different platforms and provide usage policies on top of this, that the usage of the data can be controlled by the provider of the data after it has left its own data center. And I will come back to this a little bit later on. So you may ask, what's new on this? We work on 3 basic items that are absolutely important to implement the data economy. The first thing is interoperability. IDS implements interoperability for the metadata of the data. So what we provide is a semantic data description model for the metadata. And of course, there are some technical things inside. We'll come back to the information model a little bit later. I don't think that you can really read the graphics on the lower left side. But we work on, of course, the technical part, on the APIs, on the definition of the data. But what is far more important here is the concerned community of trust, that you can identify the trustworthiness of another participant before sharing the data. So you can decide, am I willing to share my data with someone or not? Because I can classify its trustworthiness. And we can describe data as a commodity. What is the provenance of the data? What is the quality? What is the price on top of this data? And what are the usage policies? The second important thing is we are dealing with trust, because trust is really one important foundation for data sharing and data exchange. We can classify trustworthiness of an IDS participant based on certification. We provide certification mechanisms for the operational environment or the organization and for the core component that is used. So these 2 items can be measured today based on certification, and we are working on a continuous monitoring aspect so that we can do this more continuously. But this is what we have for today. And the third important thing is that we need a governance model, an accepted governance model for data sharing. That is, on the one side, of course, organizational and legal aspects, but also technical implementations of usage policies. So how to really implement usage control and not only access control. I will go in all those 3 aspects later on. So the basic idea of IDS, as already said, is that we can share data peer-to-peer from one participant to the other. We have the data consumer on the one side and the data provider on the other side. And every data exchange is only between these both parties. We have other roles, for example, a metadata broker. It's something like Yellow Pages, but you can only register the metadata of your data there. The metadata broker does not know the data itself, but the Yellow Pages service, where I can find what kind of data is available from which participant. I can simply look it up there. And here is a point where we can implement interoperability, because what I can understand based on IDS is what kind of data is available, under which technical contracts, meaning which APIs, who is providing or using the data, under what and how trustworthy is he or she, and what are the conditions for the data exchange. Because we really want to implement commercial data exchange, we implement something like a clearinghouse. A clearinghouse is really an audit-proof logging facility. I can send a log entry there. I shared data with, for example, this hash value with this other company, and both log this transaction into the clearinghouse where we have an audit-proof log. And then we can do simple things like settlement, billing for the data, but also later on a clarification. For example, if I buy data and pay some money for it, but the data doesn't have the quality that was promised to me, how can I ensure that later on that I can go to a court and say the data hasn't the quality that was promised? How can we check? So the clearinghouse provides basic mechanisms for this. The third thing we have here is a so-called app store. So what we do need really is to put some logic, some algorithms inside those connectors. The connectors are a trustworthy environment to manipulate data. But if we cannot get the data out of the connectors, we have to move the algorithms, the apps, the programs in there. And this can be done via an app store, for example, to easily inject algorithms into the connectors. The IDS information model is the core item for interoperability of the data. So, as already said, we divided it into different concerns to make it better understandable. One of the most important things, of course, is a communication concern. So, what operations can be done on which endpoint, what kind of messages will be exchanged. So I can really understand the API of the other system. And in the meaning of interoperability, I can understand if I can use this API directly, or if I cannot use this API directly. For example, there is a RESTful endpoint, but I want to use SOAP web services. We cannot solve this problem directly, but we can make it transparent so everyone understands we have to do something here. If I want to consume the data, I have to work on this communication aspect. And then I can put an algorithm and an app in my connector or in the data provider's connector and solve this problem. We can describe the context of the data, so where in space and time was this derived. We can describe, of course, the content type, what kind of resources is this, how is it represented, is it JSON data, is it a virtual machine image or whatever. And we can describe the concept of the data. So what we do not do is describe every data set, the payload of a message, for example, itself. There are existing standards to describe this, and we can link this. The IDS information model is based on the linked data principle, so we can easily link existing standards here. For example, in logistics, it's EDI or OAGIS data. It's an S administration shell, for example, or it's HL7 data when we talk about medical data. So we can link this here, but we do not maintain this domain-specific vocabularies. These will be done by other organizations, and we support, of course, the implementation of those vocabularies, but this is not our main goal. And then, as already mentioned, the most important concerns the community of trust and the data as a commodity. In the community of trust, we can describe the participant or the operational environment, the organization that provides or receives the data. So, as already said, this is based on a certification approach. So the organizational certification of IDS is based on ISO 27001. So nothing completely new, but it's really best practices of running a data center or a server or something like this. The same for the connector and all other core components of the IDS. They also get certified, and this is based on IEC 62443, or how I love to say is best practices in secure software engineering. Nothing completely new, but really important aspects to build trustworthy software. Do you share the passwords? Do you store the passwords in an encrypted storage? And all those things. These are important things that can be measured. And then there are different security profiles to identify really the trustworthiness of the connector and of the participant. And then data as a commodity, talking about the provenance of the data. Where did the data came from? Did I get it from my own IoT devices? Did I buy it from someone else? Was it used already? And so on and so forth. We can describe the quality of the data, at least as a starting point here. In my opinion, there's still a lot of work to do. And we can describe the policies and the price model for the data. As already said, IDS is a peer-to-peer approach. The data exchange is always between two connectors. So the data exchange between two connectors, only here the data flows. Every other participant, like a broker, only knows the metadata. And of course, you can use the IDS connector also as a gateway component that connects the data source and the data sink in two different data centers. But the important aspect here is that everything that can be done between those two connectors on the left and on the right can be implemented in the same way on every third connector. That means we do really have a standard for data sovereign data exchange between different participants. What this does not mean is that we cannot do something like data marketplaces. Of course, you can set up value chains of data. That one data provider provides data to a data marketplace, and the data marketplace sets up different usage scenarios for this. Maybe it makes some quality assurance on the data, or links it with other kind of data sets, enriches the data sets, and then resells the data to someone else, so that we can really set up a value chain here to really generate value out of the data. This is possible as well, but not shown in this picture. So the anatomy of a connector is quite easy and straightforward. It's very generic. Of course, we need something like a hardware or a virtual machine where the IDS connector runs on. Typically, we need something like an operating system as a foundation. And then we typically talk about something like application container management to really have strict isolation between the different aspects inside a connector. You can see on the left side the most important part. The far more important part is a so-called execution core container. So here we handle all those IDS-specific aspects. For example, the handshaking between two connectors. And this is important that before the data exchange happens, there is a handshaking between two connectors. So you can really negotiate usage contracts. So you have cool data, I want to buy them. How much money do you want to have from me for this? And the other says, okay, I want €2 for this. And the other says, no, I will only pay €1.50. And you can negotiate. You can negotiate on those aspects, on usage policies, and also on technical contracts. This is negotiable. And this is what we specify with the IDS. Then, after this negotiation is done, and both agreed on something, we do not specify the data exchange itself. So you can use any protocol that you like to use. May it be a RESTful service or MQTT, may it be a Kafka stream, whatever it may be, you can negotiate this. And then IDS has only minimal impact on this, mostly dealing with metadata and encryption of the data set itself. But the IDS connector can also support in routing the data through the connector and implementing a data bus, because you have to invoke different kind of apps, for example, or you have to enforce usage policies while using the data. And this is where the execution core also supports. Then we have identified the so-called custom container. This is a special kind of container because it connects the IDS connector itself as a trustworthy and certified environment to other data sinks or data sources outside of the IDS connector that are typically in my own security domain or in my company. For example, a database, an ERP system, or whatever it may be. You can connect the outside world here, or the internal world of your company. And in between, you can put App Store containers. You can put apps as many as you like in between, and the data router will route the data through those different kind of apps. And therefore, we have the configuration manager. Here we can define, for example, workflows or rules for the routing of the data through the different kind of apps, because typically you want to provide different kind of data or consume different kind of data. So you have to specify different workflows for different data sets. So, as already said, quite easy and straightforward, and very, very generic. And you can implement it based on every technology that you like. We have defined 4 security profiles so far because, as already said, IDSA, IDS reference architecture model is a quite generic approach. And we have to fit to all different kind of needs, dealing with, for example, logistics data that doesn't have so much need for data protection because it is there to be shared between participants. But we also want to share more trustworthy data. May it be machine data or CID files, CAD files, where a lot of intellectual property is inside, or medical data, for example, that needs high protection. To achieve this, we defined 4 different security profiles. The first one is an open profile, something like an open source profile. That means that it's not certified, and you cannot participate in a public IDS when your connector, your component is an open base connector, for example. But we have 3 other profiles: a base profile that is certified, but in a very lightweighted way. So you can easily step into the IDS with low efforts in the means of certification and implementation of technology. And if you want to have a more trusted connector, then you have to implement more things. For example, you have to implement a framework for usage policy enforcement. And we have the so-called managed or Trust Plus profile, which even requires more security considerations. For example, a hardware anchor like a TPM module. The latter 3 profiles are also defined in the DINSPEC 27017. It's a formal standard at the German DIN that we've worked on for 2 years right now, and that will be published during the next days. And so we have specified here the requirements and architecture for a security gateway for data exchange and data sharing of industrial data and services. So this is the first important step, to have this really standardized as a standardization body, and we are now going to make this an ISO standard as the next steps. And this specification enables different kind of implementations. May it be on a microcontroller without an operating system, this is possible as well. Making it on a mobile phone, for example, or implementing this in a cloud environment or a typical server environment. All those different things are possible. I have 2 examples of why we do need data sovereignty and usage policies that can be enforced. For example, if you talk about a medical data space, where a university hospital wants to share data, health data or medication plans, electronic case records, for example, with a pharmaceutical company for smart drug development, then you can state this: the usage context may only be clinical research. And you have to take at least data record with at least 150 individual data sets, and they have to be anonymized. This is what you can state. And if you are talking about industrial data, for example, you can share your CID data for production as a service. And then you may say, okay, you may only use this data for inside the machine. You may not take a look at it inside the office and examine the CID file. So, and you can put a condition on top of this, so that the CID file has to be deleted after the first use, or use it only 3 times. If you're thinking about the 3D printer and additive manufacturing, you may print this part 3 times and then you have to delete the file. And this is what we can really enforce in technology. On the other side, typically we want to share IoT data, sensor data from the machines as well. Here in the example, for example, for condition monitoring, that you want to have condition monitoring, you can share usage time, temperature data, certificates, but only for the context maintenance, and you're not allowed to forward this. Or maybe to bring it together with other machine data, that you can make a benchmark of different producers. You can put this as a policy inside. So today we typically talk about access control, and this is what we all know. You can give access to someone or to something, or do not give a grant access to someone or something. And we can put some attributes on top of it. For example, the application context. The risk management system may use the data. The ERP system may not use the data. You can put a role on top of this. If you're in the role of a risk manager, you may use this data. If you're in the role of a purchaser, you may not use the data. This is what we can do today and what everyone knows. With attribute-based access control, we can do the same thing, but a little bit better. We can identify, is the location right? Am I in the office and I may see the data? If I'm traveling and I'm in the train, I may not see the data. Is the security policy up to date? If I'm using a tablet, I may not use the data, but on a computer with up-to-date policies, I may use the data, and so on and so forth. But this is still not sufficient for really data economy use cases. We have to control the usage of the data after access was granted, meaning that we can say, yes, you may use the data, but only for certain conditions. Use it only in anonymized form, or if you use it, inform the owner, or bill it, make a settlement on this. And of course, also for the other aspect. No, you may not use the data now, or if you use the data and you're not allowed to, you want to use the data and you're not allowed to, we have to report the incident. In GDPR use cases, for example, but also in other use cases, this may be important to report this incident then. So what we do really need to move from access control to usage control, we have to define some things. We have to define the context, we have to define obligations, and we have to be enabled to provide modification and filtering of the data. And IDS, we work on this by providing a language for the specification of data sovereignty. So we do need a language to specify usage policies that is understandable, of course, on the one side, for human beings to understand what do I have to specify, what are the usage conditions that I'm willing to share my data with, and also machine readable. It has to be interoperable on machine level as well, so that different technologies for the technical implementation of usage control can be used. And what we do already know, and what is not that surprisingly, is that is not only technical enforcement. We also need organizational rules, and we still need legal contracts, because we cannot enforce everything in technology. And if we could do so, it would be awful expensive. And this is why we always say we need legal contracts, we need organizational rules, but we want to push the limit with technical enforcement to the right and maximize technical enforcement and trustworthiness based on this. To make usage policies and usage control better understandable and better usable, we've identified different usage policy classes, something like templates that you can use to better understand what can be done. And of course, the easiest one are allow the usage of the data or inhibit the usage of the data. You can restrict the data usage for a group of users or systems. For example, you may only use the data for logistics purposes, but the strategic purchase shall of course not see how many items I have in my stock. As said, restrict the data usage for purposes, restrict the data usage when a specific event has occurred. Just imagine there was an accident with a truck that carries some things, maybe you have to do something afterwards, or what is about a medical record when the person died, how to cover this, we can specify this. Use or do not use the data in a specific time interval, use it for only n times, and other things, for example, like lock the data usage information, which is a very, very mighty concept. Important is not only to control the usage, but also to find the provenance of the usage. This is one slide afterwards, sorry. We are talking here about the so-called usage control on here. So starting from access control inside an IDS connector at the data provider side, and then putting usage policy enforcement at the data consumer side. This is what the IDS reference architecture model specifies. But we have to also implement data sovereignty on the storage infrastructure, on applications, on the client side, and so on and so forth. And the farther it goes, the more complex it becomes. We with IDS, we mainly focus on the connectors at provider and consumer side, but there are other projects that cover other topics. For example, the storage infrastructure and the application. There is this project Gaia X, which also started in Germany, which focuses on a data sovereign cloud environment. And this is, of course, something that comes on top of IDS. How to bring data sovereignty in data storage? How can you ensure this? And so IDS is for data exchange and data sharing, but we have to work on this, how to bring data sovereignty in storage infrastructure and the application. And this is why we all have to be aware of these aspects of data sovereignty on usage policies that have to be stuck on this data and that have to be respected by the applications and by the people who build the applications. On top of usage policies and policy enforcement, we need something like provenance tracking to really maintain where did the data came from. I have to understand where the data came from, who provided the data in the first place, and what has been done with the data. We provide mechanisms for this, data provenance tracking and data flow tracking to really implement this. And this is necessary for a lot of use cases. But at the same time, sometimes it's necessary to not identify where did the data came from. And so we have data sovereignty, usage policies on these metadata, who may see where the data came from and who may not see this. This is also an important aspect, but I will not go into much details of this. I copied this one from a study by Arthur D. Diddle on artificial intelligence. Now, they see that there are four important things. The first thing is to provide correct data. And this is where IDS really supports the exchange of data to make data available in ecosystems, make it available to other companies, crossing security domains in the companies. And then the second important item is to really make it available. That means make it transferable. This is why we need 5G, for example, ultra-fast broadband to connect different things, to work on the edge, bring it together in centralized data sources, or just transfer the data between companies. And then, of course, we need this always available computing and storage performance. We need cloud environments. They are used today. We need high-performance parallel computing, and so on and so forth to really make use of the data and to bring different kind of data together into one data center to really analyze them. Sometimes we do not exactly want, we don't really want this. But this is where the project Gaia X is working to define such a data sovereign cloud environment. How can we specify a trustworthy cloud environment where I can see which kind of data can I store in which data set? So the idea here is not to build the new huge European data center, but to federate those different data centers. To make them interoperable, to bring one foundation to all those different data centers, and then provide additional information, metadata, to describe this. So I can easily see if I have data with a lower classification level, I can share it with these data centers, or I have data sets with a high trustworthiness level. Then I can identify which data center can I use, which cloud environment can I use to store my data, to analyze my data, or bring together different data sets from different companies, organizations, or whatever. This is what Gaia X is working on, providing a trustworthy federated cloud environment. And then I do really see, if we do have this, then we can really make use of practical data science, because you cannot make artificial intelligence, you cannot make data science without having access to data. And providing technical access to data, this is the easy story. We can easily generate data from the IoT, collect data from somewhere, transfer it, transform it, and then use it in our algorithms, in our models, train something. But we need to assess this data. But you will not get the data for free in any industrial context. You have to be stuck to the usage policies. For example, my data may not be used for commercial use, or not for military use. Or if you do something with the data and you earn money on top of this, please give me 10% of the revenue. These are all important aspects that we have to consider that come on top on the pure technology of AI and data science. If you want to know more about the different IDS topics, we provide some webinars on the different topics. You can see them on YouTube, and 2 of them are new on Open Data, the Open Data Spaces webinar, and also Data Ethics webinar. And this is how I'm going to close. So the floor is yours to any kind of question that you still have. Thank you for listening.
Thank you very much, Sebastian. This was very interesting, and we do have already questions from the audience. But before I let the audience talk, it's always my priority and privilege to ask a direct question. Yes, you said this is all set up, so we can use data for AI. I just want to know practically, so I'm an SME, how do I now get access to this data of IDS? How do I start? I mean, I have to be a member of your association, or I just can connect and then negotiate the money? Just practical for me.
Yes, practical questions are always the best. So you don't have to be a member of the IDSA, but of course every member is welcome. So while being in IDSA, you can work on the standard and you can decide how the standard will be implemented. That's a benefit for IDSA members. But the reference architecture model is open. It's open, usable for everyone. And so what you have to do is to implement something, make use of open source components, and then get started. Get someone, maybe you're really a data provider, a company like ThyssenKrupp, for example. I just want to share my data, and ask someone who can provide the technology like you used to do, and then get started, or a set implemented by yourself based on the reference architecture model. That's how to get started. The only thing that you have really to do is to enter this open IDS, this public IDS, is to get certified. And we have a little hurdle there because you have to do this, but you can start it very, very easily and then gain more trustworthiness as you like. Okay. Did this answer your question?
Yes, it answered it. And is there any restriction, like we have Canadians, for example, on board here in our audience? It doesn't matter if you're from Canada, from Russia, or Europe? I mean, it doesn't matter, no?
As long as you're stuck to the rules that we provide, of course you can start. We have people from Canada working on this. We have people from China working on this, from Japan working on this. There is no real hurdle there.
Okay, good. Thank you. So now I let the audience ask questions. We do have questions in the text questions and also a raised hand. So we start with the first question of, we have it also written and hand raised, so I'm reading it now. It's from Asunción Gomez Perez. I think he is from UPM. And his question is, are you using ODRL for representing conditional access to data?
Yes, exactly. This is a foundation. ODRL is a foundation for our usage policies. And yeah, we are working on this. I could talk now for an hour about this, but the basic answer is yes.
Okay, great. I hope this answers the question of you, else I come back to you. The second question is from Gerard Kennedy. Does IDSA standard expect to become de facto standards?
I do expect that this will become a de facto standard. I'm not convinced that this de facto standard will later on be described as IDS reference architecture model or whatever. But I think the point where we started has already got a lot of acceptance, and I think that yes, we will work together on this. So we are not the only data sharing initiative, especially in Europe and not in the world. So what we as IDSA do is we align with all those others to really eventually have a standard for data sharing and data exchange with respect for data sovereignty. And this is the important thing. I don't care about the name that is on top of this, but this is what we want to achieve, to have this de facto standard for data sharing and data exchange, because it's needed, really.
Great, yes, thank you. And now, friend from Canada, Natalie, it's a friend. Do you have partners in Canada? Natalie,
yes, we do have. I don't have them in mind right now, but just drop me a line and I will create the contact to our Canadian friends.
Great. So you can always use my email or Sebastian's email and just send your question also directly. Now, Sachin Gauer, I hope I'm pronouncing right. Dear Sebastian, this is a very pertinent topic. I want to know from standards perspective. In practice, standards like 1M2M for IoT data, has there been any interworking with it?
Yes, also with M2M, we have already worked on this, but those standards are working on different levels. What we are doing with the IDS reference architecture model is on another level than 1M2M. And we are trying to align those standards, that we have those technical communication standards, and to make it interoperable with IDS reference architecture model. We are working on this, and we are trying to do this with every standard, but this cannot be done by one single organization. So this is why we need our members to work on those topics. We are doing this not only on 1M2M, we are doing this on other standards like EDI, OAGIS, HL7, and so on and so forth.
Okay, I have a further from Sachin. One moment. I have a problem here. Yeah, it comes again from Asunción Gomez Perez. Sorry for pronouncing wrong. What is the role of ontologies in your architecture?
Ontologies are, of course, one core element in the IDS, because our information model is an ontology. And so it is important to have the semantic description of data that we do get from ontologies. So it's important. We name it a little bit different because it's better ingestible to understand. So we are talking about an information model, but the right term would be it is an ontology. And it's not our ontology that we developed from scratch. There are a lot of good ontologies available, and we reuse those ontologies. That means that our information model combines different other ontologies to have one information model for data exchange.
Okay. So here comes Sachin back. We are in a real dialogue here. Also as a comment, Sachin Gauer, also as a comment, I have been leading India EU cooperation ICT standards with IoT as one of the topics for the last 5 years. So welcome from India. I can see that this topic will be soon becoming important in India. Also, I was interacting with AI.se on the data labs. Are you also listing somewhere various data labs that want to work with each other?
No, we are not currently involved in this area, but of course we are open to this. What I see also is that it is becoming a more and more important topic for India. One of our association members is the FIWARE Foundation that is working in detail in India, especially for smart cities and also for smart industries. And so they are also working on data sovereignty on this aspect.
Okay, great. So thank you. And the last comment of him, okay, I'm also connected with Lars by Ulrich Ahle, but didn't receive a response yet, but he says thank you. So now thank you, Sachin. We let somebody else speak. Ugo Emra Sorat. Are you endorsing specific semantic web standards, for example, W3C, to minimize interoperability problems in between parties?
Yes, exactly. This what was already said is that our information model combines different existing standards. A lot of them come from the World Wide Web Consortium, of course. So it's not too many new things in there, but the combination of existing and good standards. And so we are targeting at the moment to make our information model, that is, as said, a combination of existing standards, to make this also a W3C standard in the future. But this is something that we just started to really make things interoperable.
Great. And I think the second question from Uga Emra Sorat, what kind of data integration tests are you applying on the fly? And what are the common problems occurring while ensuring the quality of the data?
So for the time being, we are a quite young association and getting really to life at the moment. So we are doing integration and interoperability tests, but these are basically based on the IDS part. So as already said, we have testing facilities for interoperability, but here we only check interoperability with regards to the data exchange based on IDS, meaning the IDS information model, meaning the handshaking between different connectors. This is interoperability that we can test. What we do not provide yet is an interoperability test for the payload. And this is something that we cannot provide because there would be too much different kind of payloads that we would have to standardize and so on and so forth. So we have the frame for the data exchange for the interoperability here. We do have test labs already to test this. There are more test labs upcoming in the future to test interoperability between IDS connectors. But what we cannot cover interoperability on payload level. And the second part of the question was about data quality. I didn't get that right.
Are the common problems occurring while ensuring the quality of the data?
There are a lot of common problems in ensuring the quality of the data, especially there are no accepted metrics available. So this is why we started to have a very generic model to describe data quality, because we haven't already identified a lot of good standards that are acceptable and used. So this is a topic that we started to work on, but we have not been digging in the deep there.
Okay, thank you. Thank you also from Uga Emra Sorat. Thank you for answering in detail all these questions. Great. And I have one more from Asuncion Gomez Perez. Is the ontology model open to the scientific community?
No, it's open to everyone. So you can find it on GitHub. It's under the Apache 2 license. So use it, take a look at it, use it. You can start with the reference architecture model that you get from our homepage, start reading a little bit on this, or just dig into the RDF model that is available on GitHub.
Great. Yes, I think we are slowly, our audience asked all the questions they needed, so we are slowly, thanks, he says thanks, thank Asuncion.
Welcome.
Thanks, Sebastian. So if you have any other questions, then please, I mean, I'm talking now to you all, the audience, please just write them directly to Sebastian or me. I forward it then to Sebastian as you like. And question, how did this all start? I mean, I know it started in Germany, and I'm German. So how this started was like from Fraunhofer Initiative, or what the idea?
Yes, exactly. So it started roughly 4.5 years ago, or a little bit more, with the proposal part that in Germany it was realized that there is a need for something like a reference architecture for data exchange and data sharing. And it was led by Fraunhofer, where 12 different Fraunhofer institutes from Germany came together, brought in their different expertise, and was funded by the German Ministry for Education and Research. And so it was a funded project, and Fraunhofer started to work on this. They built the first reference architecture model and built the first connectors and all those different things. But what was very clear in the beginning that it could not be a pure research initiative, because what was needed in this research project was the ideas, the requirements from the industry. And so it was clear that we needed something to get a settlement in the industry. And this is why the idea of the IDSA was born. The IDSA was really implemented half a year after the research project has started. And then the Fraunhofer Initiative, the funded Fraunhofer Initiative, fed a lot of content inside the association. And we as the association, we brought together different people from the industry, from research. Today we have the major RTOs, I think, from all over Europe as a member in the IDSA. And we have the floor to discuss on those things. And we are maintaining the standard. And of course, still Fraunhofer is a huge contributor to the IDSA, because they have still a lot of funded projects that are IDS related. And so this is how it started. And we started, as already mentioned, with 18 members from Germany, and we are growing and open.
Yeah, great. So thank you very much, Sebastian. This was very interesting. And as I say, more questions, please forward them directly to Sebastian and me. And now I will show you the last slide. Like always, I will announce the next cafe. And thank you for being part. I now have to go to my presentation. It always takes a moment. Here I am. I hope you may see it. It's I invite you all to come to the next live AI for You cafe session on February 26th, which is basically Wednesday in 1 week. And it will be analysis of gender bias studies in natural language processing. This time we have a Spanish speaker, Marta Acosta Yourself from UPC. It's University Polytechnic Catalonia. And please, I always ask you, write me your comments, liked it, didn't like the show, or a suggestion, new speakers and topics, if you have more questions. And also, there is always a way of unsubscribe. If you're not interested anymore, also just drop an email and I'll put you off the email list for the cafe. Thank you very much, Sebastian, for being with us today. And I wish you a good day and a good afternoon. And thank you very, very much.
Thank you very much to all of you.
So, and I might become a user of IDS data space. So if I can do it, and we see. I will ask you directly questions then.
Okay.
So, see you. See you.
See you.
Bye-bye. Bye-bye. Have a nice day.